Page 12 of functions. We're going to graph these three functions, B, C, and D. So we're going to go through and we're going to figure out different characteristics of the functions that are going to help us graph those. Okay. Just to make things go a little faster, I'm going to figure out each characteristics for each of these functions one after the other. Okay. So for example, first I'm going to figure out the horizontal asymptote of each of these functions. The way I figure out the horizontal asymptote is basically I'm going to put a big value in for x here. So if I put like a million in here, I would have 2 minus 3 divided by a million. 3 divided by a million is like a really small number. Basically it's 0. We have 2 minus 0 is 2. So we then know that our horizontal asymptote, or the number that the function approaches when x is very big, is going to be 2. Okay, so the horizontal asymptote is going to be y equals 2 in this case. Let's do the same thing for C. If we put a big number in for x, the top and the bottom, basically we're going to have a big number plus 3 divided by a big number minus 2. And so a big number plus 3 and a big number minus 2 is pretty much the same value. Big number divided by big number, which is going to be, and that's the same big number, by the way. If you have the same number divided by itself, you're pretty much going to get 1, right? So in this case of C, the horizontal asymptote is y equals 1. What about this last one? If you have a big number substituted in for the x's here, you're going to have 3 times big number divided by big number. And what about the negative 1 and plus 2? It doesn't really matter because the negative 1 and plus 2 are very small compared to the big number you're putting here, okay? Another way to think of this is you could take the top and the bottom and divide them both by x. Okay, so I'm going to divide the top by x, and I'm going to get 3x minus 1 divided by x. And then on the bottom, I'm going to get x plus 2 divided by x. And if I want to simplify that, I would get 3 divided by x minus 1 divided by, or 3x divided by x minus 1 over x. And then on the bottom, I would get x over x plus 2 over x. And if I put a huge number in for x, then this would become close to 0. This would be close to 0. And then the remaining ones, I would have, I'm going to cross out the x's here, and I'm going to cross out the x's here. Basically, I'm going to get 3 over 1, which is equal to 3, right? So 3 over 3x divided by x is 3. X divided by x is 1. So basically, it approaches 3, right? So that's a way to do it if you are more comfortable with admitting that 1 over big number is equal to 0. But if you are comfortable with the way that I said before, I think it's a little bit less algebra. So like, for example, if I have 3 times big number and I divided by that big number, basically 3 times a number divided by the same number gives you 3, right? And then, but what about the negative 1 and the 2 here? Basically, the argument is, if I make x big enough, like if I put a million in there, it's not going to really matter that that I'm subtracting negative 1 on the top and plus 2 on the bottom. It's pretty much 3 times a big number divided by a big number, right? Okay, so the horizontal asymptote in this case is y equals 3. What about the vertical asymptotes? Vertical asymptotes occur when you have 0 in the denominator. So in this case, for example, when do we get 0 in the denominator? We're going to get 0 in the denominator when x equals negative 1. So our vertical asymptote is x equals negative 1. What about this one here? When do we get 0 in the denominator? If x equals 2. So our vertical asymptote is x equals 2. What about this one here? Our vertical asymptote occurs when x equals negative 2. So that is x equals negative 2. Okay. What about the domain? The domain is naturally calculated immediately after you figure out the vertical asymptote, and the reason why is because the domain is all possible x values, and the vertical asymptote is kind of the opposite. It's kind of, the vertical asymptote is x values that where the function does not exist. So if I found out that the vertical asymptote is x equals negative 1, then I know that the domain is x is not equal to negative 1. If I know that the vertical asymptote is x equals 2, then I know that the domain is x is not equal to 2. If I know that the vertical asymptote is x equals negative 2, then I know the domain is x is not equal to negative 2. What about the range? The range is directly related to the horizontal asymptote, right? The range is the y values, all possible y values, and the horizontal asymptote is the y values where the function does not exist. So if the horizontal asymptote is y equals 2, then the range is going to be y is not equal to 2. If the horizontal asymptote is y equals 1, the range is y is not equal to 1. If the horizontal asymptote is y equals 3, then the range is equal to y is not equal to 3. Okay? All right. X-intercept. The way we calculate x-intercept, we take y and we set it equal to 0. So that means we're going to have 0 equals 2 minus 3 over x plus 1. How do we solve for this? Well, we just use algebra, and we're going to subtract 3 over x plus 1 to the other side. We're going to get 3 over x plus 1 equals 2. Then we can multiply both sides by x plus 1, and so we'll get 3 equals 2x plus 2. And then we'll subtract 2 from both sides, and we'll get 2x equals 1. And basically, we'll find out that x is equal to 1/2. And that is our x-intercept. Okay. What about our x-intercept for the next one? So we have 0 equals x plus 3 over x minus 2. Now, to figure out when this is equal to 0, we just need to figure out what the numerator is 0. When is x plus 3 equal to 0? It's equal to 0 when x equals negative 3. So the x-intercept is x equals negative 3. That was a lot easier. So you see it's more convenient when it's in this form than when it's in this form. Okay, what about D? So for D, we just set 0 equal to 3x minus 1 divided by x plus 2. When is the numerator equal to 0? It's equal to 0 when x equals 1/3, right? X equals 1/3. Okay, so we just found all the x-intercepts. How do we figure out the y-intercepts? To figure out the y-intercepts, we set x equal to 0. So we're going to take the equation y equals 2 minus 3 over 0 plus 1, which is minus 3, which is negative 1. So the y-intercept is going to be negative 1. What about the next one? If we put in x equals 0 for this one, we're going to get y equals 0 plus 3, which is 3, divided by 0 minus 2, which is negative 2. So our y-intercept is negative 1/2. Last of all, for D, if we have y equals 3x minus 1 and x is 0, we have negative 1 in the top, and then x plus 2 when x equals 0 is going to be 2 in the bottom. So our y-intercept in that case is negative 1/2. Okay, our behavior as the horizontal, or as the function approaches the horizontal asymptote and the vertical asymptote, I think it might be easier if we just draw this instead of actually figuring it out like we did on the last page. And so let's just graph it and then we'll figure out the behavior, okay? All right. So, for example, for B, let's first draw our asymptotes. Our asymptotes are at y equals 2 and x equals negative 1. So y equals 2 would be that line. X equals negative 1 would be this line. Okay. What about C? For C, it would be y equals 1, x equals 2. So y equals 1, x equals 2. For D, it's y equals 3 and x equals negative 2. So y equals 3, x equals negative 2. Okay. Now, the next big clue is the x-intercept and the y-intercept. So for the first one, B, the x-intercept we know is 1/2 and the y-intercept is negative 1/2. So let's draw that. So 1/2 and negative 1/2 and negative 1. So the x-intercept is 1/2, and the y-intercept is -1. Okay? So basically we can see that it's going to look kind of like this, right? And one thing that we're going to learn about hyperbolas is that it's a reflection about the diagonal axis. So if you know that the right side looks like that, the left side is going to be on the top. Okay? Now let's do the next one. So the next one, we know that the x-intercept is -3, and the y-intercept is -1/2, which is about, I'm sorry, the x-intercept is -3, so that would be here, and the y-intercept is -1/2, which is here. Okay, and then so the opposite side is going to be reflected kind of like that. Okay, and last of all, we know that the x-intercept is 1/3, x-intercept 1/3, and the y-intercept is -1/2. So we know that the function kind of looks like that, and so the top part's kind of looks like that, right? Now you could graph the opposite sides better if you plug in one x value. Like for example here, you could plug in x = 4 and then figure out exactly what the y value is for that point, and that would let you graph the opposite side better. Okay. So if we're going to write about the behavior, now that we've graphed them, it's easy to write about the behavior. For example, for the B graph, the first one, let's look at that one. So as x approaches positive infinity, we can see that the y value is going to approach, that's y = 2 from the bottom. So I'm going to write 2 negative. As x approaches negative infinity, then y approaches 2 from the top, right? And as x approaches, and now we're going to look at the vertical asymptotes, -1. So as x approaches -1 from the left, I can see that we're going to approach positive infinity, right? Y approaches positive infinity. As x approaches -1 from the right, then we approach negative infinity, right? Because we're going down here. Okay? So that's the behavior of B. Now we can do that with the others too. So for example, for C, I can see that if x approaches positive infinity, y is approaching y is approaching 1 from the top. As x approaches negative infinity, y approaches 1 from the bottom, right? And as x approaches x = 2 from the left, I'm going to approach negative infinity. As x approaches 2 from the right, I'm going to approach positive infinity. Okay, what about D? So D is this one here. And if I'm approaching positive infinity on the x, then I can see that I'm going to approach y = 3 from the bottom, right? As I approach x is negative infinity, then I can see that I'm approaching y = 3, y is 3 from the top. And as I approach the x asymptote of -2 from the left, then I know I'm going to approach positive infinity. And as I approach -2 from the right, then I'm approaching negative infinity. Okay? All right. And that's it for this top part. To watch number 2, please go to the next page 12 video.